So we saw how when rays of light approach a concave mirror from far away, it could be that the concave mirror is facing the sun, for example. So the rays of light are coming in parallel to the axis, and there are several rays of light that are coming in. And we talked about paraxial rays. When the rays are paraxial, meaning they're close to the pole, they get reflected and all of them meet at one single point known as the focus of the mirror. Now, the assumption of paraxial rays is important because if the rays are not paraxial, so let's look at this ray here, which is not close to the pole. The orange rays are close to the pole, but this ray in pink is far away from the pole. What happens when this ray of light is reflected? So CD, C is the center of curvature for the mirror. CD is the normal at point D. It's normal to the surface. And so by the law of reflection, this right here is the angle of incidence. And so this angle of reflection is going to be the same as the angle of incidence. So if this were, let's see what happens when this is close to 60 degrees. 60 degrees. What would happen? The angle of reflection would also be 60 degrees. And if you consider the fact this is horizontal and so is the principal axis, this angle here is got to be 60 degrees as well. So in triangle DCE, this point here being E. So in triangle DCE, we have two angles that are 60 degrees. Angle D and angle C are 60 degrees. So angle E, so angle D, E, C, that's got to be 60 degrees as well. That's because the total of the three angles of any triangle is 180. So if two angles are 60 degrees each, the third angle has got to be 60 degrees as well. So DCE, that is an equilateral triangle. What that means is DC, the length of that is the same as CE. The length of DC and the length of CE is the same. The length of DC is nothing but the radius of curvature. And so CE is equal to the radius of curvature. So, well, we know that the pole distance from the center of curvature is also the radius of curvature. CP is the same as, the length CP is the same as CE. That can only be possible if E is the same as P, if point E is the same as P. So a ray here in pink that is not paraxial, it's pretty far from the pole. In this case, it's incident at an angle of 60 degrees to the normal. It meets the principal axis not at the focus, but actually at the pole of the mirror. At the pole of the mirror instead of the focus. So that's where the assumption of paraxial rays is important, in that if the rays are not paraxial, they do not meet at the focus.